Hi everyone, today we're going to work on properties of logarithms. Our essential question is how can we use properties of logarithms to simplify problems? So we're going to use properties to simplify problems and algebraic expressions. So here we have a list of properties that we have for logarithms. The first one is log of m to the power of n. This is when we have log of a power. In this case, in order to simplify, we can change it to the power times the log of the base. So this can be written as the power, which is n, times the log of the base. And the base is m here. So log of m to the power of n can be written as n times log of m. Next one is log of a times b. This is when we have log of a product. In this case, we can change it to sum of the log of the factors. So here, a times b, the a and b are the factors, so I can write this as sum of the log of the factors. So log of a plus log of b. So that's how we simplify it. And the next one is log of a quotient. So when we have log of quotient, that can be written as a difference between the log of the numerator and the denominator. So I can write this as log of the numerator, which is a, minus log of the denominator, which is b. So these are the three rules that we can use for simplifying logarithms. So let's do some examples here. The first one here, we have log base 3 of a squared base cubed over c to the power of 4. So as I'm looking at this log expression, the first thing that I see here is a division. So I have a quotient, I can change it to subtraction. So I can write this as log of the top, which is a squared b cubed minus log, I forgot the base, log base 3 of the denominator, and that's c to the power of 4. So that's the first step. I'm not going to stop at this point because I want to make sure I have simplified this as much as possible. Can I simplify this more? Yes, I can, because as I look at the first expression, I see that here I have log of something multiplied by something else. So this is log of a product. How can I simplify log of product? Using this rule. So I can write this as log of a squared plus log of b cubed. And the next one, I'm just going to write that here at just for now. The bases were 3. Don't forget about the 3's. And log of c to the power of 4. Now look at the terms that I have here. They are all log of power, like this one. So I can move the power to the front. So any term that I have here with the power, I'm going to move the power to the front of the log. Like this one can be moved here. This one can be moved here. So I can rewrite this as 2 times log base 3 of a plus 3 log base 3 of b minus 4 log base 3 of c. And I cannot simplify this anymore, so this is my answer. This is my final answer. Okay, now let's work on the other problem. Log of x to the 3 times 2x plus 1, 3x minus 1. Whenever you're expanding a logarithm, the first thing that you need to look for is a division. Do I have a division? Then change it to subtraction, like this one that we did. Then you look for multiplication. Do I have any multiplication? Yes, like this one. So I change it to plus. And the last thing that I'm going to look for is the exponents. Do I have any term with exponent? If yes, then move the exponent to the front. So we're going to do the same thing here again. Do I have a division here? No. So I'm going to go to the next step. Do I have multiplication? Yes. What am I multiplying? I'm multiplying x cubed by 2x plus 1 by 3x minus 1. Basically, we're just finding the factors, and then we can simplify. So I'm going to simplify this in this way. So log of 3 factors multiplied by each other, I can write them as sum of log of the factors. So I can write this as log base 9 of x cubed plus log base 9 of 2x plus 1 plus log base 9 of 3x minus 1. So this is the first step. Now I need to look if I have anything else that I can simplify. Now again, do I have division? No. Do I have multiplication? No. Do I have exponents? Yes. There's one term here that has exponent. So I can move this to the front. So I'm going to write this as 3 log base 9 of x. I move the exponent to the front. And then, can I simplify this? No, because this is not multiple or division or exponent, none of them. So I cannot simplify this. I'm just going to write it as it is, like 2x plus 1 plus log base 9 of 3x minus 1. Okay, now let's go to the next problem. In this problem, we have log f cubed times x to the 4 over y to the power of 1 over 3. Okay, so once again, do I have any division? Yes. So I'm going to change the division to subtraction. Log of top, which was f to the 3, x to the 4, minus log of the bottom, which is y to the power of 1 over 3. Next step, do I have multiplication? Yes. So here I am multiplying f to the 3 times x to the 4. So I can write this as sum of logs. It will be log of f to the 3 plus log of x to the 4. Do I have any multiplication here? No. So I'm just going to write this here for now. Okay. Next, do I have any exponents? Yes, on all of these terms, I have exponents. So I can move the exponents to the front. Okay, so it will be 3 log of f plus 4 log of x minus 1 over 3 times log of y. And that's my final answer. And this was for the previous one. Okay, now let's go to the next one. Okay, for this one, we have log of 5x to the power of 1 over 2 times y times z to the power of 3. So, do I have any division? No. Do I have multiplication? Yes. What am I multiplying? 5 times x to the half times y times z cubed. So I can change them to sum. It will be log base e of the first factor, 5, plus log base e of the second factor, x to the half, plus log base e of the next factor, plus log base e of the last factor. So we separated the factors and wrote as sum of the logs. Next, do I have any exponents? Yes, on some of them I have exponents, so I'm going to move them to the front, like here. And this one will be moved here. So I can write this as log of 5 base e plus 1/2 log base e of x plus log base e of y plus 3. So you move the 3 to the front of log base e of c. And this is my final answer. I cannot simplify this anymore. Okay, now let's work on the second example. In this example, we are writing each expression as a single logarithm. So basically what we're doing here is the opposite of what we were doing before. So before, we had one single log and we were expanding that. But this time, we have several logs and we are going to write it as a single log. That means we are basically condensing this. Okay, so this is inverse of, basically opposite of what we were doing before. So what I'm going to do here is to use the same properties but the other way. So this time I have the right side of the properties and I'm going to go to the left side. Okay, so in these cases, we need to look for coefficients first. Like, does any log have any coefficient like this one? Yes. So I'm going to do something about this. Then, do I have addition? Then use the property for that one. Do I have subtraction? Then use the appropriate property for that. So what happens in each case? If I have coefficient behind the log, that means it was basically an exponent, so I'm going to move it back. If it was coefficient like here, I'm going to move it back to the power. So that's the first one, if I have a coefficient. If I have addition, that means it was basically log of product. So addition of logs can be written as log of a product. Just write one log and multiply the factors here, multiply the arguments here. And next is if you have a subtraction, that means it was basically a quotient. So you can write this one, the first one, as the top of a fraction and the second one as the bottom of the fraction. So we're going to use the same thing here. Okay, so first of all, I look at the terms that I have. Do I have any coefficients? Yes. So I'm going to move them to the power. So this can be written as log base 3 of m plus log base 3 of n. Sorry, this is n to the power of 2. So you move the 2 to the power. Next, I'm going to keep the negative. Just look at the coefficient that you have here. Just take this one, not the negative. Log base 3 of p to the power of 2. So you move the coefficients to the power. Next, do I have any addition? Yes, I have an addition here. So I can write these two as just one log. So I'm just going to write one log for these two and multiply the arguments here. M times n squared. So this is log of m times n squared. And the next one was negative log 3 p squared. Okay, now, do I have any subtraction? Yes, I do. So I'm going to rewrite these two, condense them as one log, and write them as log base 3 of top. So the first one will be the top of your fraction. So I'm going to write m times n squared divided by the second one, p squared. So now I have only one log, one single log, And that's my answer. Okay, let's work on the next one. Again, first step, do I have coefficients? Yes. So move them to the power. So it will be log base 2 of 5 plus log base 2 of x to the 4 minus log base 2 of y to the 5. So once again, notice I'm just moving the 5. I'm not going to touch the negative. I'm going to work on the negative later. Okay, next. Do I have addition? Yes, here I have addition. So I condense it as 1 log base 2 of the first one, which is 5, this one, multiplied by x to the 4. So 5 times x to the 4. Then I had minus log base 2 of y to the 5. Now, what do I have? I have a subtraction here. So I can rewrite this as a fraction, as a quotient of this one, the first one, and the second one. So I will have log base 2 of the top is the first one, 5x to the 4 over the second one will be the denominator, y to the 5. And this is our answer. Okay, let's go to the next example. Again, do I have any coefficients? Yes, 2, 2, and 3. These are the coefficients. So I can rewrite this as log base b of x plus log base b of y squared plus log base b of z squared minus log base b of r to the power of 3. Okay, now do I have any addition? Yes, I have addition between 3 terms. So I can rewrite them as 1 log, and then the argument is going to be all these multiplied by each other. So this will be log base b of x times y squared times z squared. Then the next term was log base b of r to the 3. Okay, now what do I have? I have a subtraction, so I can rewrite this as a quotient. So it will be log base b of the top, which is the first one. The first one is going to be the top of the fraction, x y squared z squared over the second one, r to the power of 3. And that's it. This is our answer. Oh, sorry. I meant to highlight this. So this is my answer. Now let's do the next one. Okay, what do we have here? We have some coefficients. So move them to the power. And this one can be written as a power again. So I'm going to rewrite this as log base 4 of 25 plus log base 4 of x squared plus log base 4 of y to the 3 minus log base 4 log base 4 of 25 to the power of 1 over 2. And guess what? If we have 25 to the power of 1 over 2, what does that mean? We have learned before, if we have a fraction on the exponent, that means we have a radical form here. So I can write this as radical. You know that this one is the cowboy, so it can be written inside the house, and this one is the horse, so it should be sitting at like the outside of the house, so it's here. Now, this is basically square root of 25, and what is square root of 25? It's just 5. So this can be written as, this one that you see here can be written as square root of 25, which is just 5. Okay, so I'm going to rewrite this as log base 4 25 x squared plus log base 4 of y to the 3 minus log base 4 of 5. Okay, then what do we have? We have some additions here. So I can write them as a multiple. So I'm going to write this as log base 4, just one log of 25 times the second one, x squared, times the next one, y to the power of 3, minus log base 4 of 5. Okay, this time I have a subtraction, so I'm going to rewrite this as log base 4 of top, which is 25 x squared y to the 3 over 5. Now look at the fraction that we have. Can we simplify this fraction? Yes, because 5 divided by 5 is 1, 25 divided by 5 is 5. So I can simplify it and write it as log base 4 of 5 x squared y to the 3. And we know that if the denominator is 1, we don't have to write it. So this is just my answer. My final answer is this. Okay, now we're going to use the properties that we learned to solve the log equations. So let's say this example, we have log of 2 base 3, log of 7 base 3 equal to log of x base 3, and we want to solve this. It looks a little bit hard. How can I solve this? The best way is to use the properties and simplify the expression as much as possible in a way that we have one log on each side. So if I have, let's say, for example, one log on each side, I say log of, let's say, a base 3 is equal to log base 3 of x. And I ask you to solve this. So you're going to say, if I have two logs with the same base equal to each other, that means the arguments are also equal to each other. So basically, I can say I can drop the log with the base and then just set a equal to x. So if I can simplify all these log equations in a way that I have one log on each side, then I can use this rule to solve for my x. So let's see what we can do here. So on this one, I have two logs on the left side. Can I simplify this and condense this into one log? Yes, because I see an addition here. I can rewrite this as log base 3 of 2 times 7. This is equal to log base 3 of x. And notice I can only do this if I have the same base for all the logs. If they're all having the same base, then I can do this. If I have different bases, then I cannot use any of these rules here. This is the rule only for the logs that have the same base. Even for all the properties that we had here, the base should be the same. Everywhere, the base should be the same. Okay, so now let's go here. 2 times 7 is 14. So this will be log of 14 base 3 is equal to log of x base 3. Okay, now if I have two logs with the same base equal to each other, that means the arguments are equal to each other. So I can basically say I drop the logs and I have only 14 over equal to x. And this is my answer. I solved for x. Now let's go to this problem. Okay, the left side is already just one log, so I'm fine with the left side. But the right one, I have 1 over 3 times log. So something is here multiplied by log. Let's get rid of that one as well. So what is this? This is a coefficient. Can I simplify it? Yes, I can move the coefficient to the power here. So I can rewrite this as log base 5 of m equal to log base 5 of 125 to the power of 1 over 3. Now, what is 125 to the power of 1 over 3? We know that this is equal to radical 125. The cowboy goes here and the horse goes outside. This is the third root of 125. What is third root of 125? It's equal to 5. So this is basically just 5. So I'm going to rewrite that. Log base 5 of m is equal to log base 5 of 5. Okay, now I have two logs, one on each side. I'm going to drop the log and just set the m equal to 5. So we solved for the variable here, m equal to 5. Now we're going to go to the next example. So this example here is a little bit more complicated. We have two logs on one side and another two logs on the other side. So we're going to condense them into one log on each side. What do I have here? I have addition. So I can rewrite this as log base 9 of 5 times x plus 1. Okay, so the first one multiplied by the second one. And the right side, again, we have another addition. So I'm going to rewrite that as log base 9 of 6 times x. Okay, now I have one log on each side. And the base are the same for both of them, so I can drop them and say, okay, what do we have? We have 5 times x plus 1. Just the arguments are equal to each other, equal to 6x. Now I can solve this for x easily. First of all, distribute. So we have 5x plus 5 equal to 6x. Now I can subtract 5x from both sides. And then we have 5 equal to 6x minus 5x is x. And we're done. X is equal to 5. Now let's do the last example. We have log of 42 base 5 minus log of 6 base 5. And on the other side, we have only one log. So let's condense their left side as just one log. It's subtraction, so I can write it as a quotient. So log 5 base 5 of 42 divided by 6 is equal to log base 5 of x. Okay, now I can drop the logs because I have one log on each side. And now what is 42 divided by 6? It's 7. So I have only 42 divided by 6, which is equal to 7 on the left side and the x on the right side. And we're done. This is our answer. Okay, now I'm just going to talk about one more thing for this lesson for you. Here we have some common errors that students might make when they're working with logarithm properties. Keep all this in mind. So this is the rule for product. We have learned this before. But the common error that sometimes the students make is this: when they see log of m plus n, they think they can change it and separate it as sum of two logs. No, we cannot do this. This is not equal to this one. We only change to product if we only change to addition if we have a product here. So only log of m times n is equal to log of m plus log of n, not this one. So this is the first mistake. The second one, sometimes they write, the students write, log of m plus n equal to log of m multiplied by log of n. This one is also not right. Do not make this mistake. Then we have this one. If you have log of m minus n, can I write it as log of m divided by log of n? No, we cannot do that. Only if you have log of a fraction or quotient, then you can change it to subtraction between two logs. Next error could be this one. If you have log of m times n, can I separate the factors and just write log of m times log of n? No. Or if I have log of m over n, can I write this as log of m divided by log of n? No, none of these work. And the last one is when you have log of m plus log of n, can I write it as subtraction between two, the product between two logs? No. So make sure you keep these common errors in mind and do not do these mistakes when you are working on log problems. This was today's lesson. Have a great day.